All right, welcome back, Hononegah, Algebra 1. Today we're going to do 7-4, solving polynomial equations in factored form. So this is kind of the basis of us throughout this entire chapter is going to be about factoring and then solving when it's in factored form. So there's two forms really that you're going to have to worry about. There's standard form and there's factored form. And there's a way to solve in standard form, but really we're going to focus in on the way to solve in factored form. So factored form basically means that you have broken it down into its factors. So in the first one, x is a factor and x plus 2 is a factor. And then the second one, x minus 3 is a factor and x plus 8 is a factor. Now, where this comes into play then is what's called the zero product property, basically stating if I have two items, A and B, and it equals 0. So there's two caveats there. So you have two things being multiplied together, and you can have more than two things being multiplied together, and it has to equal 0. If that is true, then A or B must be 0. Think about that for a second. If I have a number and an x, and it equals 0, then x must equal 0 in order for that to be true. Because if I have two things multiplied together and they equal 0, then one or the other must be 0. Now, where this comes into play in factored form. Anytime you have factored form, and they're being multiplied together, so the factor x plus 1 is being multiplied by the factor x minus 3, set the factors equal to 0 and solve. So set the factors equal to 0 and solve. What that means is you put -1 into the problem, that causes the first factor to be 0, and 0 times anything is 0. If you put +3 in, it causes the second factor to be 0, and again, anything times 0 is 0. So that is the basis behind factoring or solving something in factored form. So the 3x is a factor and the x minus 2 is a factor. So anytime a teacher asks you to solve something in factored form, set them equal to 0 and solve. So notice we have two factors in the next one. 2x plus 7 is a factor. 2x minus 7 is a factor. Subtract 7 and divide by 2. Add 7 and divide by 2. Now, this one, anytime you have a binomial being squared, write it twice. Now, you don't necessarily have to solve both factors because you get the same factor, or you get the same answer, sorry, for each factor. And C has 3 factors. Now, you are never going to actually be factoring in which, I shouldn't say never, you're rarely going to be factoring in which there's 3 of them, but set each of the factors equal to 0. So I subtract 1, here I add 3, and here I add 2. So every time there is a factor, set it equal to 0 and solve. You try. So go ahead and hit pause, and you try these 3 on your own. All right, welcome back. Again, set each of the factors equal to 0 and solve. So in the first one, x is equal to 0. I didn't have to solve that. So the first factor equaling 0, and then x minus 1 equaling 0, and I had to solve. So the second one, 3t is a factor, and t plus 2 is a factor. So t equals 0 and t equals -2. And the last one, I have two factors here, z minus 4 equaling 0 then, and z minus 6 equaling 0. So add 6 to both sides and add 4 to both sides. Now, the next one we're going to talk about is actually doing the factoring ourselves. So take out the greatest common factor. We talked a little bit about this in the previous section, where you're taking out the highest number and or letter that can be taken out of everything. So in the first one, they are both divisible by 2. Don't actually divide by 2. Take out the 2. It's the opposite of the distributive property. If I were to multiply the 2 into the parentheses, I would get the original question back. So this is taking out something instead of putting something in. So what can I take out of both? Now, neither one is divisible by the same number, but I can take an s out of both. Not a big fan of s's because they look like 5. So if I take one s away from both, then I'd have 3s cubed plus 16. So in the next one, I can take out a number and a letter. So both of them are divisible by 7, and I can take away 2 w's from both. So if I divide by 7 and take away 2 w's, and if I divide by 7 and take away 2 w's, notice if I distributed this back in, and I'm not saying you have to show your work here, but if I were to distribute this back in, I would get 7w to the 5th minus 35w squared. So it's the opposite of distributing. I'm taking the number out instead of putting the number in. So the last one, I can take a 5. Both of them are divisible by 5, and both of them have an n. So then if I divide by 5 and take away an n, if I divide by 5 and take away an n. So after you have taken the number out or divided that out, what is left in the parentheses after you do that? So how do I solve an equation then? So first, I have to write the equation so that one side equals 0. So again, that's not the problem in any of these, but I need it to equal 0. Then I need to factor out, and then I need to set all the factors equal to 0. So in this first one, forget about the equal 0 part. Just take out the GCF. Now this gets into what we learned today. Once it is in factored form, set the factors equal to 0 and solve. So the key part about this is taking out or getting it into factored form. So first make it equal 0, which you did. Then take out the GCF. Now I'm not a big fan of having a negative in front, but we'll go ahead and take out a negative 5n. So if I divide by negative 5, I'm going to take a negative and the 5 out and take away 1n. So I'm left 2n minus 7. Once I have it in factored form, set the factors equal to 0 and solve. So again, the key to this, it's not an x, it's an n. So going through this step by step one more time. First, make sure that the equation equals 0. Then factor it, in this case factoring out the GCF, and then next set the factors equal to 0 and solve. Set it equal to 0, so that's not the problem. Take out the GCF, or take out the greatest common factor. They're both divisible by 6 and a c. Now, this is one of the most common mistakes. If I take out a 6c, if I'm dividing it by 6, 6 divided by 6 is still 1. So there is still a 1 in the parenthesis. Once I have it in factored form, set the factors equal to 0 and solve. So the next one's the first time it doesn't equal 0. I always like to keep my lead coefficient or my highest number as positive. So I went ahead and subtracted 6k to move everything to the left-hand side. Then take out the GCF. They're both divisible by 3 and a k. So I divide by 3 and take away a k. Once I have it in factored form, set the factors equal to 0 and solve. So in the next one, by the way, E is, I believe, a quiz question, just letting you know. So I first needed to equal 0, so I subtracted 10x. I then am going to take out the greatest number and letter I can, so GCF. Once I have it in factored form, set the factors equal to 0. And so I get x is equal to 5 halves. That's a horrible looking 5, so I'll do that again. 5 halves. Last one is a U try. So go ahead and hit pause. Welcome back. So I need it to equal 0. I then am going to take out the highest letter and or number I can. So the highest number I can take out is 4. and I can take away 1m from both. Once I have it in factored form, set the factors equal to 0. I get m to equal 0, and I'm running out of space here, so I subtracted 2 and divided by 7. I get m to be negative 2/7. This is just factoring. It's not solving. So please make sure you're clear on that. If there's no equal sign in the question, they are merely asking you to break this down. And the only reason they put this back in there is because there's more than one letter, there's numbers, there's letters that I could take out of each. So each of them is divisible by 2. I can take away 1a from both and 1b from both. So if I divide by 2 and take away an a and a b, so divide by 2 is 4, take away an a, and then I took away the b. Divide by 2 is 3, take away the a, and take away 1b. So this next one, I can take a v out of all of them. There is no number that I can take out of all of them, but there is at least one letter I can take away from all of them. So this is about as hard as I can make this. They're all divisible by 3, and I can take away 2 q's from each. So it's what you can take out of every single one of them. So divisible by 3, and take away 2 q's. Divisible by 3 and take away 2 q's. And divisible by 3 and take away 2 q's. So the last one's the starred question. Hit pause. All right, welcome back. So if you tried this one on your own, you can take away a 7 and a y from each one. So if you divide by 7 and take away 1y, and divide by 7 and take away 1y, you're left with 7y parentheses, 2y plus 3. So that concludes the notes for today. Your homework assignment's all the way back here on the front. 3 through 19 odd, 25 through 37 odd. All the answers will be in the back of the book as you check your answers. This is the start of solving in factored form. And so there's going to be a lot of questions throughout this chapter in which you'll have to factor, and then sometimes in which you'll have to factor and solve. So this is the beginning of solving by factoring. If you have any questions, please make sure you talk to your teacher, and good luck.